Okay, this is a video for extra practice with capacitors. We start with the 24-volt source here, and C1 and C2 are in series, C3 and C4 in series, and then we have C5. Now, all three of these are in parallel with each other. So we reciprocally add C1 and C2, that's 1.33. We reciprocally add C3 and C4, that's 0.75. Then we redraw our circuit. Here's our 24 volts. And then we have all three of these in parallel. In parallel, we just simply add them all up. So our C total is 8.08 microfarads. Now from here, we have to get the chart filled out. Okay, each one of these will have 24 volts across it. This branch will have 24. This branch will have 24, and so will this. Because they're all in parallel with each other with the 24-volt battery. So I record 24 volts, okay, for our 6 capacitor, and then 6 times 24 gives me 144. Now, I will then look at each of the branches here, the ones that are in series. The first one, I'll take 1.33 times 24, and that'll be the charge value on both of those. So 31.92 on both of those. And likewise, I'll take 0.75 times 24 to get 18 microcoulombs across both of those. Then I'll divide each of these by their capacitive values to get their volts. And notice how 6 plus 18 equals 24. And again, 8 plus 16 over here gives you 24 volts. Because that's a series circuit. They should the volts should add to be 24 for both of those. Now next, determine the total energy stored by the capacitors. I'm just going to take 1/2 the C total times 24 volts, which is our volts total, and get basically 2.3 millijoules, or 2,327 microjoules. Okay, next question here. So we have 3 capacitors. Well, 100 microfarad, a 50 microfarad, and 33 microfarad. They are to be connected, so the total capacitance is 45.3 microfarads. Okay, now we can connect them in series, parallel, or combination. I know this is going to be a combination because if it was in parallel, the total of these would be all added up. If they were in series, the total capacitance has to be less than the smallest capacitor. This is in between, so I know that it has to be in combination. Then it's just a matter of figuring out, maybe guess and check. I put the 33 and 50 in parallel and the 100 in series with the battery. And these two just get added up because they're in parallel. So that's 83 between them. 1 over C total equals 1 over 100 plus 1 over 83. That gives me a C total of 45.3 microfarads. Now you might wonder how I could guess that. Well, 45 was kind of halfway between all these, so I figured this would be the combination. Now, if I was wrong, I would just try another combination in there. So anyways, my C total is 45.3. Now I take 9 times the 45.3 to get 408 microcoulombs. That 408 microcoulombs is on the 100, but it's also on the parallel combination here of 83. So I take 408 divided by 83, I get 4.92 volts. That has to be the volts on both of them, since these are both in parallel. Now I'll just multiply each of these, okay, by their capacitor and voltage, and I'll get their charges of 162 and 246. Please notice that these two here add up to be the 408. Reminding that a parallel circuit is a charge divider circuit. A series circuit is a voltage divider circuit. Okay, now one last question here. A parallel capacitor has a value of 22 microfarads and is attached to a 9-volt battery. While that battery is attached, the plates are then separated even more so that the distance between the plates is 3 times the original distance. Okay, well, let's take a look at this. Determine the potential difference between the plates after they are moved. Well, since the battery is still attached, it has to be 9 volts. So what effect does this have on the electric field when you move them? Well, if the distance is 3 times V equals ED, volts stay the same. Distance is 3 times the distance. The electric field then has to decrease by a factor of 3. All right, last, what factor does the energy stored on the plates change after they are moved? Well, the charge must decrease by a factor of 3 because the capacitor value just went down by 3. So we can just use 1/2 CV squared if we want to. So U equals 1/2. We're going to have C divided by 3 because the capacitor value just went down by 3 times V squared. So if that's true, then the energy should have decreased by a factor of 3. And that's our review for capacitors.